It's all in here. I told you that you will need this table eventually, every single day, over and over and over again, and today's the day. I also told you a long time ago you need to get one of these somehow, either electronically or printed, so that you can see these small numbers right in here. Because here they come. I hope you have it. If not, hurry, you need to get it. Every student in period 1 had the table and they were able to read those small numbers. So I know it works. How do you get these in seconds and skipping all of this crap? Look right here. Look right there. That's what you are going to use from now on. All you have to do is find that little number. Yes, I know it's a tiny little number. That's why I put 4 different versions of this table in Canvas, so you can find the one that works best for you, so you can read those numbers. If you can't read those numbers, you better find another version of the table that I placed in Canvas to help you. So here they are. There those numbers are. So barium +2 oxidation number, strontium +2 oxidation number, yttrium a +3 oxidation number, zirconium a +4 oxidation number. You don't have to do this anymore, but you know how it was produced. You know how these are developed, and now you know how to use them to form formulas. Now, we do have a problem in a situation, and it's not your fault. Topic 5, I only scratched the surface of topic 5. Topic 5 would take me about 4 months to complete from the beginning to the end and not skipping any parts. Here's the problem. Look at niobium. Niobium has 2 possible oxidation states. Yes, I hate to tell you this, but the size of the atom, the number of electrons orbiting the nucleus, changes their behavior in terms of them losing electrons. Because look, if you go over just one atom from 41 to 42, now look at the number of options for molybdenum to lose electrons. He could lose 6, 2, 3, 4, or even 5. There's so many rules, and some rules are specific towards certain atoms. And that's why topic 5 would take me 3 months. I can't spend that time on that. Your question should be, okay, I see that I have oxidation numbers. Which one do I use should be your question. You're going to use the bold one. That's why I said you need to have a table where you can see these numbers. You see chromium? If you have your own table, grab it now. Find number 24, and I hope that you can see that that 3 is in bold print. If not, you need to obtain another version of the table that I placed in Canvas, because that bold print is what you're going to use. We're all going to use the bold print in the first part of topic 9. So I see vanadium, his bold number is a 5. I see titanium, his bold number is a 4. Manganese, it's a 2. So I would use that 2 for him if he was in front. Okay? Now we have another problem, but it's easy to solve if you listen and watch the problem. Okay, watch and listen. Nitrogen. Look at nitrogen on the table. Look at his options. That's why I'm telling you, it would take me months to complete topic 5. Nitrogen has the ability to lose a wide variety of electrons. 3, 5, 4, and 2. Now, take a look at that little plus and minus that's in front. We all need to understand what they mean by that plus or minus, so watch this carefully. I'm going to get rid of this. And when I look at nitrogen, I see a plus, minus, 3, 5, 4, and a 2. That's what's on the table. Now that's the shortcut version. What do they really mean when they write it this way? This is what this means to you and me. Watch this plus and minus sign. That plus or minus only goes for the first number in the list. That plus or minus does not carry through to every single number that's on the table. It's only the first one. So I will have a -3 and a +3. And then after that, they're all positive. +5, +4, +2, as you can see right down here. And remember, I will always have the negative element in the back. The negative atom will always be in the back, and look what we found with our electron configuration. We found that he would lose or gain 3 electrons and become a -3. There it is. So it matches. But yeah, I'm not going to lie to you. Nitrogen can do some really weird things with his electrons when it combines with other atoms. He can lose 3, lose 5, lose 4, lose 2. Now the probability decreases to the right. And honestly, I think humans get involved with these ones on the far end. You're going to have a hard time finding phosphorus that's going to lose 4 electrons. Now with human influence, we probably forced phosphorus to do that. So it decreases as you go to the right. Okay. So what does this mean for you? This means you no longer have to go through all of this. To get these oxidation numbers, you simply will find the element on the table, and you're going to grab the bold number. The guy in front will always be positive. The guy in the back, you're going to have to go to the table and get his only negative option. Negative option. I think it's time to practice this. So let me get rid of this. Oh, I'm going to need to get rid of all this as well. Okay, so what are you doing now? Oh, heavens, check this out, man. I don't know, what am I on, number 3 or something? I really don't care. Hey, look at this, look at this. Let's go with scandium. And let's add that scandium to a chlorine and get scandium chloride. I'll walk you through this entire problem. Here's what you already know. He's positive. This is already negative. That's what you already know. Metal, non. Positive, negative, ionic. Second step. Let's search the table for scandium. Let's get his oxidation number. If there's more than 1, you have to pick the bold. Oh, but this is easy. Of course that is just the first example. Scandium has only 1 possible number, and that number is a 3. Chlorine. Look this guy up. There he is. Oh no. Now I'll see if you were paying attention. Based on that short version, you should know his only negative option, which is -1. We need to get these to add up to 0. Is there a shortcut in doing that? Yes, listen to this massive shortcut to get this thing done like that. The shortcut is called drop and cross. You will hear that for the next 4 months from me. Drop and cross, drop and cross, drop and cross, drop and cross. Drop. What does drop mean? Drop means drop the signs. Cross the numbers. And believe it or not, you're done. Now, how does that work? How does that work? Okay. We found he was a +3, and we found he was a -1. Well, it looks like I would need three -1s to add to a +3 to get the 0 to show up. I need 3 -1s when added to a +3 to get that 0 to show up. 1, 2, 3. How many scandiums did I actually have to use? Just one. Happened to be at a +3, but I used just one. That's the power of drop and cross. Within seconds, you can get these oxidation numbers to add up to 0, and you're done. Now, to polish this up, to make it a final answer that I would accept on your assessment that goes toward your grade, no, you don't need to write the 1. And don't get mad at me, you can't keep all that garbage up there. You can't keep it. You gotta get, okay. All right, let me do one more. And then I'm going to give you a series of practice problems, which looks just like your assessment coming up in the future. Okay, let me see. Oh, here you go. I'm going to find out if you're awake or you're watching TV. Let's take a titanium. What is a titanium? Oh, beautiful. And now let's throw it in with a phosphorus. Okay, that T is quite large. Hey. Okay, stop it. Hey, you want a tip? I'll give you a tip. Use your table. All right, I'll walk you through this one. My very first thing I already know plus, minus. I already know that. That's the way it is rest of the year. Titanium. Oh no, he's got 2 numbers. That's okay. Pick the bold one. And I see on my table that the 4 is the bold print. Phosphorus, well, I know he has to be negative because he's in that second spot, and he is the non-metal. Oh no, look at the options for phosphorus. You have to remember what their shortcut means to you. There is only one negative option. And the only negative option for phosphorus is a -3. No, you don't use that 5. I know it's in bold, but that's +5. Phosphorus in this spot has to be negative, and your only negative option is a -3. I need these to add up to 0. Well, to do that, I'm going to quickly drop and cross. I'm going to drop the signs, cross the numbers. You're done. I just crossed them. That's all I did. Again, how does that work? Well, he was positive, he was negative. 4 times -3 gives you -12. 3 times 4 gives you 12. That and that added together gives you your third favorite number, 0. That's the power of drop and cross. Now, I will tell you this. You have to be careful with drop and cross. It will work like 99.5% of the time. And that 0.5 is going to catch you off guard, which actually I'm going to show you today where you got to be careful with drop and cross. Okay. I think I better pause and ask for questions. Okay. Take those 4, use your table, get those oxidation numbers, drop and cross, and get those formulas. Okay, I'm going to do the first 2, and I'll let you continue to finish 3 and 4. So if you want to kind of watch me again, I'll do 1 and 2. Okay, remember the routine, my friends. The routine is straightforward. Plus, minus. Well, that's on every single one. I know that. Okay, watch me do number 1. Vanadium. Yikes, he has 4 possible options. It seems to be his most stable and most common is a +5. That sucker will lose 5 electrons. Oxygen, well, I know he's on this non-metal side, and at least oxygen is very straightforward, especially from your topic number 5. Looks like he has a -2. I'm just going to simply drop the signs and cross the numbers. 2 and 5. And yes, you would erase those, but I want to keep those up there so you could see. 5 times -2 is -10. 2 times 5 is a +10. +10 plus a -10 is 0. Ooh, did you find him? I think that's the longest process in these kind of problems. Searching a table, 118 elements. Yeah, it's going to take you a while. I know it does. There's niobium right there. Oop, and he has 2 possible numbers. Looks like niobium has a +5 for his most common. Why did I give you 2 +5s? Oh well. It don't matter. Nitrogen has to be negative. You know he's a non-metal. You know he's over on the right side of the table. Ooh, bunch of options for him, but his only negative number can only be a -3. Okay, well, I can drop and cross those 2. I'll bring this down here, and I'll bring that 5 right there. Okay, I'll give you a few more minutes to wrap up 3 and 4. Hurry. Number 3, let's see. Zinc, sorry, not zinc, zirconium, sitting right here. Zirconium has a beautiful +4. Fluorine, well, you know he's a non-metal. He's way over here. And that guy, nice, man. No choice. -1. Okay, I'm going to simply drop and cross. That 1 has to go here, and then I bring that 4 over here. You go back, you erase the charges, and you really don't need this 1 sitting there. You can get rid of that. You can erase that. Did you like number 4? Number 4 is a good one. If you were paying attention, then 4 shouldn't have been a problem. I hope you were. Let's see what's going on. Let me get rid of this. Iron. There he is. And it looks like it's a bold 3 for iron. And I know he's positive. Oh boy. Selenium. Yeah, that was the one that looks kind of weird and tricky. But my friends, I told you already that it has to be negative. The second guy is always negative. So if you look up selenium, you can't use that 4. His only negative option is a -2. You have to use the -2. Okay, well, I'll just simply drop and cross and I'll be done. I'll put a 2 here, and I'll just simply bring that 3 down here. And it's good night. I'm done. Good. Yes, they do. You're right. Yes, they become more challenging. And let's take a look at one that's a little more challenging than before. Let me get rid of this. Questions before I erase this huge mess of mine? Okay, let's take a look at the next level problem dealing with the same concept. Let me get rid of this. Let me get rid of this. Okay, yeah, you might have problems like this. Let me find a good one here. Yeah, let's try this one. Let's try taking a chromium, which is, and let's add that to a carbonate. That's carbon and oxygen. That is not 3 of those. No. That's a lowercase oxygen, or lowercase o. This is a capital O for oxygen. You might as well stop. You're not going to be successful. It's because you're not using the correct table. This is where that second table is going to save you a lot of heartache. This is that second table that I placed in Canvas that you need to get a hold of. I don't care how you use this. You can print it off like I have on paper. That's probably the number 1 thing to do. Number 2 would be to have this open in some tab that you can simply refer to. I don't know, you know your situation. Here's where you use this table for the next 4 months. You are still combining 2 things together. It is still going to be ionic, but it contains a covalently bonded substance that required extra electrons to obtain your octet from topic number 8. No, I did not do these to you in topic 8. If we were in person, yeah, I probably would have tried one of these. I normally don't do them. So don't change how you do this. Don't change. Here's what you're doing. You're going to simply take this chromium and you're going to combine it with the CO3. And again, look what doesn't change. This is still positive, and that still has to be negative every time. Chromium. Okay, so no change so far. Look up chromium, and you have to get his bold number because he has multiple possible states. Looks like chromium has a bold number of 3. Now comes the change. You have 2 different atoms combined together covalently that were short electrons and therefore needed to obtain electrons from somewhere else. But I'm going to save you a headache. All you do now is look up this substance, and this substance is called a polyatomic. Poly means many, atomic means small, and they're polyatomic ions because they have a charge. Poly is many, atomic means small, and ion means they have some kind of charge. And here's their charges: -3, -2, -1, +1, and a -4. My friends, all you have to do is look them up and get that number. And there he is. There's the CO3 polyatomic ion, and right there is his oxidation number, or you could use the number that's in the column at the top. So I know he is a -2. And now you're back to the old tricks. You need to drop and cross these oxidation numbers so they add up to 0. Now I would really watch this, because this is where drop and cross can cause a problem. Okay, watch my drop and cross. Here, I'm even going to change colors, so I think it's going to be beneficial if you can see it in colors. So +3 for him, and he was a -2. Okay, watch this now. I'm going to drop and cross, which means this 2 is going to come here. This 3 is heading over. This 3 is heading over here. What's missing? Yes, your favorite symbol. Hey, you don't want 33 oxygens. So guess what you need to wrap around this CO3, because you want 3 of them. Yes, look what comes back. Parentheses. Okay, so we looked at parentheses when we did percent composition. I told you it's going to come back. Here it comes. So now, if you need multiple of these, 2, 3, 4, or even 5 of these, you must now wrap them in parentheses, because you do need 3 of these. Because 3 times -2 is -6. And then 2 times +3 is a +6. And a +6 added to a -6 is your 4th favorite number, 0. Okay, if you have this, get ready to use it. If you don't, what I'm going to do for you is I will give you their charges. So we'll do a couple of these. I'll give you their charges to save you time, but after today, you're responsible to have your own table. So, what do you need? I'll keep this up here as an example. Man, I don't know what number I'm on, and I don't care, and I don't think you care either. Okay, so here you go. I am now going to use this and this on these. Okay. Why don't you guys try this one? Take a calcium and add it to an NO3. And right here at the top, I will give you his oxidation number. See NO3? Well, there he is. I will give you their oxidation number today. When I see you on Monday, probably not going to happen. All right, my friends, hurry. Put those 2 together and get the formula. And I don't know, I've lost track. Okay. Another one. Oh, look at this. Actually, don't look at this. Hurry, do this one. C6H5O7. All right, fine. I'll start numbering these. 1, 2, 3. And this guy is a -3 to help you out. And let's try. Oh yeah, how about a hafnium? And how about a C7H5O2? And his charge is a -1. Okay, let's just do those 3. Would you please combine these 3 over here? Ionic bonds. Get those oxidation numbers to add up to 0. Okay, I'm going to start with number 1. I'll start combining those. If you're not done, keep going down there at the bottom. Okay, here we go, my friends. Looks like I got a calcium. I've got a nitrate off of that polyatomic ion table. Calcium, when you looked him up, he should have been a +2. I gave you his charge as -1. You must drop and cross. So that 1 would go here. You don't have to write it. The 2 goes here. But if you need 2 or more of these off of this table, you must use parentheses. And then you'd have to erase those numbers on the top. Magnesium, C6H5O7. When you looked up magnesium on the table, you found that he was a +2. I gave you his charge as a -3. Yeah, you better drop and cross those. This 3 is going right here. This 2 is going over here. And again, if you're dropping a number 2 or larger, you better use your parentheses. Yes, they can get quite nasty looking. Hafnium and a C7H5O2. And the game continues. Hafnium, I think he has a +4 off of the table. And then this guy I gave you was a -1. Okay, I'll drop and cross that. That 1 goes here and actually does nothing. Here comes the 4, which means, okay, it's 2 or more. I better use some parentheses. And yes, you have to go back and erase all those lovely stupid numbers, but that's the answers, my friends. Here's the last part for today. All of you, find your table and look at the next part of topic 9. This is part 1, so we're done with part 1. Here comes part 2. Part 2, we've got a problem that we need to solve. And your problem is this. Let's take RU and let's add it to carbonate. Okay, here's our problem. Here's the problem. All of you, are you ready for this? Get it? Okay, are you on the table? There he is. Look. Oh man, that'll make you want to go home. Look at that. Look how many bold numbers he has. Whew. Dude, we got a problem. I am so glad you're here. We need to fix this problem. So, guess what they're going to do to you now? What they're going to do to you now is they're going to have you calculate their oxidation number. So look at this carefully, because this is the second part of topic number 9. What they want you to do is go back and determine what that oxidation number is. Or they might ask you to determine what this oxidation number is. Yeah, sit down and watch this. Let's just deal with this one first. So how do these problems look? Here's how these problems actually look. And I'll still use this. Watch this. This is how they look. We're trying to find this. And what they'll do is they'll underline the part of the compound they want you to determine or calculate. So they're going to do this to you. When you see the underlined part, they want this. So if this was underlined, they would want to know what they'd want to know what that is. Okay? So the underlined one is what you're answering. I think if I were you, I would just sit back and pay close attention to this and watch my steps. Watch my steps. Okay. Very first step. I find the one that's underlined, and all I do is I put a question mark underneath him, because don't even look him up. Don't look up the one that's underlined, because if you do, you just wasted 5 minutes, because he might be one of those that has multiple bold numbers and you don't know what to do. Never look them up. You will have to look up his partner. Now, his partner will help you determine their charge. You will have to look up that one, and he's on this table, and there it is. He's got a -2. These questions actually have two parts. They've got oxidation number, and then they've got total atoms in the compound. Okay, watch this carefully. So, underline, don't look them up, put this. You do look up his partner, and we found that there is a -2 for his charge. You have to go back and look at how many CO3s are actually here in the formula. No, there's not 3 of them. There's only 1 of them. There's only 1 CO3. So you multiply it by 1. If there was 3 here, you would have to have this. Okay, now I have 3 CO3s. But without the parentheses, hey, you only have 1 CO3 there. And I'll do the math. Okay, well, if this right side is -2, this left side has got to be the opposite for them to add up to 0. So I know that the whole right side has got to be a +2, the opposite of this side. You're not done yet. You need to have it per individual RUs. So you have to look and see what number is sitting right here in the lower right-hand corner. Now, this one's an easy one because it's the first one. You have to end with a division. Always end with some kind of division. There is only 1 RU in this formula. That's this. He has to be the opposite of this side so that these two add up to 0. And the math is actually this freaking simple. +2 divided by 1 is +2. That is this answer that they want from you. Total number of atoms. You got to go back and count now. Grand total. Hey, looks like there's only 1 RU here. Looks like there's only 1 carbon. Looks like there's only 3 oxygens. 3 plus 1 plus 1 is 5. That's part 2. And I think we need to stop now. So when I see you on Monday, that really weird day, I hope you're logged in, man, because I'm going to continue this and I'm moving on. Being absent doesn't excuse you, suckers. I'm moving on. Okay, I think that's a great place to stop. Your assessment for topic 8 is still due Monday if you're ready to take that. All right, my friends, have a great weekend, and I will see you on Monday.
Thank you. Have a good rest of your day.
Yes, you too.